All right, let's talk about the different types of systems of equations categorized by their solutions. We've got three types, right? You got the normal type where they just cross. One solution, boom, done, no problem. You got a potential, if you have linear equations, you have a potential for lines that are parallel. If lines are parallel, they never cross. They have no solution. And then we have a third kind, right? If you have two lines, if you have two equations, well, those two lines could coincide. There's actually two lines drawn right here. They coincide. They have the same solution absolutely everywhere, right? So we have situation 1, situation 2, situation 3. Now, they're called different things in different places, but the big idea is this, right? We have one solution, no solution, or infinitely many solutions, right? So a lot of places they call the one solution consistent and independent. And that's where you just, again, you have one solution, the lines cross in one place, it's beautiful and easy, right? You have inconsistent, which is no solution, and that's the situation when things are parallel. So that would be the word inconsistent. So an inconsistent system has no solutions. Now you have consistent dependent. Dependent would refer to two lines that coincide, so they're exactly the same line. They have infinitely many solutions. Whatever's the solution for one is going to be the solution for the other, right? So sometimes you run into these things. Now, we'll talk about how they look, how they come up algebraically in a later video. I wanted you to see them visually, and I also want you to understand that when you do come across this, if you forget, right, check this out. When you do the algebra, which we'll see later, and you could write this down right now, it's a normal, no problem, regular, one solution system. If you're doing your math and you end up with x equals a number, y equals a number, you know, you got your beautiful old coordinate, your x comma y, and it works out wonderful, and it works out lovely. That's how it works. But if they turn out that they're parallel, what you're going to end up with is you're going to end up with a statement that's never true. You're going to do all your math, you're going to do everything right, and the variables are going to cancel each other out. They're going to disappear. They're going to make zeros, and you're going to end up with something where you have one number equals another number. That's obviously not true. It's never true. So if you have a number equals another number, those two lines turn out they're going to be parallel. They're inconsistent. It's an inconsistent system. There's no solution. And then the third situation is you're going to do all your math, you're going to do everything right, you're going to isolate the variables, you're going to try to get everything on one side, all the numbers on one side, the variables on the other. The variables are going to cancel each other out again, and you're going to end up with something like 5 equals 5. You're going to have a number equal itself, something that's always true, and that's when you have those lines that coincide. You have infinitely many solutions, because what that means is no matter what number you put in, it works. This means no matter what number you put in, it doesn't work. This means you only have one set of numbers, one pair, one x, one y that works. You have one solution, no solutions, infinitely many solutions. Crosses once, parallel, coincides.